Welcome. In this video, I am going to solve NEET 2022 previous year questions in physical chemistry under the topic of some basic concepts in chemistry. Let's see the question. The first question is very easy. The density of the solution is 2.15 gram per ml. The mass of 2.5 ml solution in correct significant figure. They are asked a significant figure. Okay. First, we need to find the mass. Okay, the mass. Okay, they gave density, then the 2.5 ml is nothing but a volume is expressed in ml. Okay, they gave density and volume, they are asking mass. This is so simple. Rho is equal to m by v. They gave rho, they gave volume, just multiply, that's it. 2.15 gram per ml multiplied by 2.5 ml. ml get cancelled, we will get answer in the unit of gram. The gram is a unit of mass, that's it. 2.15 multiplied by 2.5. The exact, we need to find the exact value because significant figure. 2.15 multiplied by 2.5, it will give 5.375. Okay, there is a significant figure. According to the significant figure rules, if we multiply two decimal numbers or else we divide two decimal numbers, take only the lowest one. Okay, if we add, subtract, take highest decimal numbers number. In the case of multiplication or division, the number which means the one with the lowest decimal, we take this. Okay, just to take, this is a 37 greater than 5. Okay, 5.4, this is the answer. 5.4 grams is the answer. Okay, there is a two rule. The first rule is for the addition and the subtraction, the significant figure follows the number with more decimals. In the case of multiplication and division, the significant figure follows the number with the low decimals. That's it. The next question, what fraction of Fe exists as iron 3 in iron 0.960, which means FeO, metal oxide, iron oxide. Considering Fe 0.690 to be made up of Fe2 and Fe3 only. How to approach this question? This question is very simple. It is nothing but a stoichiometry. Fe can be in plus 2 plus 3. They given that plus 2 or else plus 3. Oxygen only in minus 2 state. This is a rule. Okay. Iron oxide or some majority metal oxides are neutral in nature. Okay. If oxygen is minus 2, iron should be plus 2, so that total charge is 0. This is the rule. Okay. Now they gave 0.69 iron only. Okay, 0.69 iron only. Okay, to neutralize one O2 minus charge, one Fe plus 2 minus charge is required, but that is 0.96. But it, which means it shows us there is only Fe2 plus, there is also Fe3 plus, because Fe3 plus contains plus 1 charge. Here it is plus 2, here it is plus 3. So Fe2 plus contains somewhat Fe3 plus. So one amount of, which means less than one amount of iron is required. Okay. Let me tell one time. To neutralize one O2 minus charge, one Fe2 plus charge is required. But they given 0.96 gram of iron is required to neutralize minus 2 charge of oxygen, because there is not only plus 2, there is also plus 3, because it contains plus 1 charge extra. That one extra charge contribute. So iron only 0.96 time is required. Okay, this is a statement. How to approach this question? Because they are asking what fraction of iron in Fe3. How many Fe3 in the Fe 0.96? How many Fe3 in the fraction? It is very simple. Okay. The iron 0.96. In 0.96 there is Fe2 plus, then Fe3 plus. Okay, we don't know how many Fe2 plus, how many Fe3 plus. We don't know the both. Okay, then in 0.96 X amount of Fe2 plus is there, then 0.96 minus X amount of Fe3 plus is there, or else X amount of Fe3 plus is there, 0.96 minus X amount of Fe2 plus is there. We can take anything because we don't know anything. Okay, I am choosing the first one. Okay, anything you can choose second one also. I choose the first one. Okay, right. So how to write this? Okay, then I am erasing because I don't have any space. Okay, then Fe plus 2 plus Fe plus 3, which is equal to oxygen. Okay, in the which means in unit, sorry, in the unit of charge. Okay, there is X amount of Fe2 plus, it contains plus 2 charge. Okay, there is 0.96 minus X amount of Fe3 plus, it contains charge 3. There is only one oxygen, it contains charge 2. Okay, right. This is very simple because plus 2 iron in X times plus 3 iron in 0.96 minus X time satisfies the minus 2 charge. This is a statement. You can do vice versa. X can go here, 0.96 can go there. It is based on convenience. That's it. Okay. This is a statement. If we find X, it will be Fe2 plus. Okay. What is X? If we solve mathematically, X exactly can be determined. Okay. The X can be 0.88. The X is 0.88. If we solve using scientific calculator, the X is 0.88. Okay. Then Fe2 plus is 0.88. What is Fe3 plus? Fe3 plus is 0.96 minus a 0.88. 0.88, which is nothing but 0.08. Okay, this is very simple. Okay, don't panic. Only way is to solve the charge. Okay, because iron oxide is neutral, so oxygen contains minus 2 charge, so iron should contain plus 2 charge, but there is Fe2 plus and Fe3 plus, hence Fe2 plus and Fe3 plus mixed, so one instead of one ion, less than one ion is required. Then how many charges are contributed by Fe3 plus? That's it. Okay, right. So we finally found the fraction of Fe3 plus ion, 0.08. So this is the answer. That's it. Yes, but it is wrong. Okay, they are asking fraction. This is just the amount of Fe3 plus. It is not a fraction. Okay, this is not an answer. The fraction means in 0.96, 0.08, which means 0.08 divided by, it means 0.08 divided by 0.96. This is a fraction. Okay, this is not a fraction. This is just this much of Fe3 plus. In 0.96, 0.08 amount of Fe3 plus present, which means 0.96 of, if we minus 0. Okay, this is this amount of Fe2 plus and this amount of Fe3 plus mixed to give plus 2 charge, so that the minus 2 charge of oxygen is neutralized. Okay, then the fraction means in the total, which means in 0.96 how many Fe3 plus present, that is a fraction, which means 0.08 divided by 0.96, it will give 1 by 12. This is answer, because many people is confusing with this. This is the amount of Fe3 plus, The 1 by 12 is a fraction of AP3 plus. Okay, they can ask anything. The only key tool is nothing but a charge. Charge should be balanced. That is the only way. Okay, this is the simplest question. Then this is very simplest one. In 1 molar solution that contains 0.5 mole of a solute, that's it. Very simple. 1 molar contain 1 mole in, they are given in grams. So I am also taking grams, 1000 grams. Instead of taking 1 kg, I am taking 1000 grams. 0.5, 0.5 mole. 0.5 mole, what is, everything will be reduced by 2. 0.5 mole, oh, sorry, 0.5 mole. Okay. 0.5 moles, 0.5 moles. Okay. But 1 molar solution, 1 molar solution, okay, 1 molar, but there is only 0.5 mole. Mole is reduced by 2, then it is also reduced by 2. 500 gram. If we divide this, what is the answer? 0.5 divided by 500. 0.5 divided by 500. That is nothing but 1 molar. That's it. Okay, because 1 molar contain 1 mole divided by 1000 kg, which is nothing but 1 into 10 to the power minus 3. If we take this as in kilogram, it is 1. For only we take this gram, so it is 1 into 10 to the power minus 3. If we take it is in kilogram, it will be 1. Okay, right. 0.5 divided by 500, it is also gives 1 into 10 to the power minus 3. Because we take weight in gram. If we take weight in kilogram, it will be also equal to 1. Okay. If we reduce to moles by anything, the weight of the solvent is also reduced by the same thing. Okay. Like 0.5 mole divided by 500 gram of the solvent. That's it. This is very simplest one. Like the first question. The second question is little difficult. Okay. Yeah, this is a very difficult question. What mass of 95% pure calcium carbonate will require to neutralize 50 ml of 0.5 molar HCl solution according to the following reaction? This is a reaction. In this reaction, 1 calcium carbonate, which means 1 mole of calcium carbonate react with the 2 moles of HCl. This is a neutralization reaction because it forms water. Okay, that's it. They are asking what mass of 95% pure calcium carbonate. They are asking calcium carbonate mass. Calcium carbonate is only 95% pure only. It is not 100% pure. Okay, 95% pure calcium carbonate required. How to solve this? There is only one hint. 50 ml of 0.5 molar HCl. Okay, 50 ml of 0.5 molar HCl. We can find the moles of HCl easily from the data. Okay, 0.5 molar, capital M. Molar is equal to moles divided by volume of the solution in liter or milliliter. They gave 50 milliliter, which means in 1000 milliliter, okay, in 1000 milliliter, we take only 50 milliliter, okay, so that the 50 milliliter of 0.5 molar HCl contributing. Okay, look at this statement, not look at this equation. This equation is just a reference, okay. Think about it. In 1000 ml, only 50 ml of 0. molar HCl is reacting with the calcium carbonate, so that the neutralization happens. Okay, 50 molar in 1000 ml, which means 50 molar, sorry, 50 ml, 50 ml in 1000 ml. Okay, this is the answer. This is a volume of the solvent. This is the volume of the solvent. That's it. Okay, all right. If we put here 0.05 will be there, then multiply these two, we will get 0.05 Sorry, 0.025. This much of moles in HCl. HCl contains 0.025 moles. Okay. I am erasing this 0.025 moles. We find the HCl moles, which means how many moles of HCl present. Okay, 0.025 moles. 0.025 moles. Okay. Then find moles of calcium carbonate. After that, we can find the gram of calcium carbonate. How to find moles of calcium carbonate? We require the help of chemical kinetics. Okay, this is a reference reaction. Okay, take this reaction. This is a reactant, then this is a reaction. Write rate law. That's it. Okay, the rate law is nothing but decomposition of calcium carbonate. Decomposition of calcium carbonate. I take this as just a C because the calcium starts with a C, which is equal to 1 by 2 of, because there is a 2 moles, everything should be in stoichiometry, so d by d of HCl. Okay, convert this into moles, which means moles of calcium carbonate is equal to 1 by 2 of moles of this, moles of HCl, that's a 0.025. If we divide 0.025 by 2, we will get the moles of calcium carbonate. Okay, the moles of calcium carbonate is 0.0125. This is the moles of calcium carbonate. From this data, we find moles of HCl, then moles of calcium carbonate. Moles of calcium carbonate is 0.125. Then we can convert into the gram. That's so easily. This is so easy. Okay, 0.125 moles of calcium carbonate is there. Okay, then how to convert? This is so simple. 0.0125 moles multiplied by calcium carbonate atomic weight, sorry, calcium carbonate molecular weight, which means molar mass, anything. Okay. Molar mass contains the unit of moles per gram. In the case of calcium carbonate, 100 is the molecular weight, molar mass, gram per mole. Mole per mole get cancelled, that is 100. If we multiply 0.10125 into 100, we will get 1.25 gram. Okay, this is for 100% pure calcium carbonate. We didn't consider 95% pure calcium carbonate up to this. Okay, after this we can consider the 95% purity. Okay, how to find the 95% pure calcium carbonate in this? Okay, 95% pure in this. Okay, right. 1.25 is what? It is for pure or impure. Okay, right. They are asking what mass of 95% pure. Okay, we have a 95% pure calcium carbonate. In that calcium carbonate, how much mass is needed? But they didn't tell 95% calcium carbonate is how much gram is present. They didn't tell anything. Then how to solve this? Okay, so in 95% pure calcium carbonate, 1.25 gram is needed to neutralize the 50 ml of 0.5 molar HCl solution. Okay, right. This is in 95% pure calcium carbonate. Okay, listen, 1.25 gram is in the 95% pure calcium carbonate. Okay, we need to find the impure or else the normal calcium carbonate. Okay, because they are told us to take this equation, right? In this equation there is no calcium carbonate has 95% purity. Okay, this mass is associated with the 95% purity. Okay, we need to convert into impure, which means add 5% impure calcium carbonate to this in the unit of gram. Okay, then how to solve this? There is a one formula. Okay, the impure sample is equal to pure, just a minute, pure sample divided by purity. This is a formula to find the impure sample. Okay, impure sample is equal to pure sample divided by purity. That's the thing. Impure sample multiplied by purity, it will give pure sample. That's it. Okay. We have pure sample, which means 1.25 gram. Purity is 0.95 because 95 percentage. 0.95. If we divide, we will get 1.31 something value, 1.315. Which means this is an answer. Okay. The final one will be different because impure substance multiplied by purity, it will give pure substance. That's it. The formula is rearranged. Okay, that formula is rearranged. Then we can find the answer according to this. Okay, because there is two. This is also present. This is only for 95 percentage pure. Okay, 95 percentage pure calcium carbonate. Okay, but in this equation does not contain anything. That's it.